Today, 95% of the engineering needed to build the stations and space planes seen in the movie 2001 has already been developed by NASA as part of its Space Shuttle program. Many of the film's technical advisors were NASA engineers who in the 1960s also designed the actual wheel-shaped stations and space shuttles, which NASA soon hoped to build. Budget cuts after the moon landings forced NASA to only develop the space shuttles, and the development of the space stations was dropped for over 15 years. But NASA's best-kept secret is that many of those early shuttle designers believed the shuttle program could achieve both goals. Many of those visionary designers now working with the Space Island Group are going to finally achieve this goal. Early space station designs centered on the shuttle's hollow orange external fuel tank, known in the industry as the ET. While the two white rocket boosters under the shuttle's wings drop off 2 minutes after launch and parachute into the sea, the 70,000-pound aluminum ET stays attached to the shuttle, feeding its liquid fuel to the shuttle's engines during the rest of its 8.5-minute flight to orbit. Few people realize that one of these airtight cylinders is carried to orbit on each shuttle flight, then destroyed when forced back down into the atmosphere when its odorless hydrogen-oxygen fuel is gone. NASA's engineers originally wanted to attach small engines and guidance systems to the ETs to keep them in orbit, then add a connector to their lower end and join a dozen of them together to form the wheel-shaped stations similar to those seen in the movie 2001. The interiors would have the sensation of 1/3 normal gravity, making walking, showering, eating, and even dancing practical yet exotic. Well over 100 ETs have been carried into space and destroyed so far. The Space Island Group is taking this original concept a step further. We will create a fleet of dramatically improved, safer, and lower-cost shuttles to carry up to 100 people at a time into space. And we're modifying this new shuttle's ET to become the building blocks of our space stations. Excess oxygen and hydrogen will be drained off, and the empty tank will be retrofitted for habitation or special uses, such as research and manufacturing. The flight to orbit will take about 10 minutes, and the approach to the station will take just another hour. A space tug will lift the passenger compartment from the shuttle's frame, carry it to the station, and attach it to the center column receiving area. When the passengers leave their seats, they'll move right into the station. These design improvements will be far simpler than the original shuttle program in the 70s. NASA is giving us data from over 100 actual shuttle flights to draw upon, and hundreds of the original NASA and aerospace engineers are joining us as advisors and/or project engineers. Designing the original shuttles without today's computers took thousands of engineers 8 years. Our workforce will be several hundred, and our first flight will take place in just 4 years. Developing our new versions of the space tugs that NASA designed in the 1980s will take about another 100 engineers and approximately 3 years to complete. Our new ETs will be much simpler than the existing NASA external fuel tanks. The main change will be the addition of an extra section to the ET's lower end and interiors designed to permit easy retrofitting for human habitation. The extra section can be outfitted in advance as living quarters for nearly a dozen people, or designed as a connector, allowing the nose of one ET to be attached to the opposite end of another, as the wheel-shaped station is formed. Our final piece of new hardware is an unmanned dual ET launcher made up of a regular ET filled with fuel, with shuttle engines on its lower end and a set of liquid-fueled rocket boosters for added thrust. The second unfueled ET can carry 100 tons of supplies to the station, or have its interior completely outfitted in advance to become a free-floating zero-G factory or a zero-G stadium able to broadcast sports and entertainment events to a worldwide audience. These zero-G ETs could float alone or be clustered into larger groups. The fuel tanks from the booster rockets will also be left in orbit to become spokes of the wheel-shaped stations. Most of the station's electrical and plumbing lines can be installed in the ETs down here on Earth, as can the attachment points for the floor, wall, and ceiling panels to be installed in orbit. At this point, you may be asking, if this is such a good idea, why isn't NASA and the aerospace industry doing it? As a government agency, NASA is prohibited from operating a commercial enterprise. Their mandate is to develop the hardware, then let private industry take over. But the firms that built the shuttles and ETs for NASA only work on government-funded projects. They have no contact with commercial companies who could buy or lease these shuttles and stations. Their design, construction, and purchasing procedures, geared to complex government requirements and very small production runs, can't mass produce the dozens of shuttles and hundreds of ETs this project will need. Our management structure will have far more in common with the airline and computer industries than with the defense industry. We'll work closely with the firms who will lease these stations as research facilities, space hotels, hospitals, factories, or entertainment centers to let them profit from their involvement long before the first station is operational. Millions of adult consumers who were teens during the Apollo landings and the release of 2001, as well as hard science fiction fans, have been waiting decades for their personal access to space. Those under 25 can't remember a time when televised shuttle launches weren't commonplace. A safe passenger-carrying shuttle is no harder for them to accept than a new jetliner is to their parents. In fact, astronauts say that once they explain NASA's very limited goals to student groups who've grown up on space video games and movies, they lose most of their audience's interest. Public expectations about space have been driven by the fantasies of the film and video game industries far more than by NASA. We believe that entertainment companies can best convey the immediate excitement of our project. Our first dual ET launch in 2006 could carry up the world's first zero-G sports arena. Its interior could be outfitted here on Earth, complete with cameras able to broadcast the games worldwide. The very idea is a publicity bonanza. Beginning this fall, students around the world could be asked to suggest hundreds of individual or team competitions which could be held in this stadium. They'd suggest the rules, the clothing, the lighting, and even how contestants could move without gravity. The ET interiors will duplicate various sized living quarters for station guests, house the station's broadcast and entertainment section, feature a functioning gourmet restaurant, and showcase the advanced hydroponics area that will grow food for the station's guests and staff. We agree with the assessment of Young and Rubicam's Carl Harmon that promoting this project can be the most powerful marketing opportunity this decade.